Hello.
Hello, Dr. Panasik. Good to see you.
It's great to see you. Glad to see you're doing another guest lecture. This is awesome.
Yes, thank you so much. And I hope you are doing well with your family.
Yeah, things are going well. Things are going well.
Yes.
Have you had a chance to look at some of those flips?
No, because Friday is my day that I am free. I work back to back Monday to Friday morning. So today I have time, and tomorrow during the weekend I'll be able to do that.
Okay.
But I
Okay.
saw instruction. It looks like it's straightforward, and you had shared it before, but I had not had a chance to look at it. So I'll look at it and go through it, and if I have glitches, I will let you know. But I thought the instruction was very straightforward. Yes, I look forward to actually
Oh,
going.
oh, good.
Yes.
So I went ahead and I sent out that link for the pre-questionnaire.
Yeah.
Make sure in your settings that you allow anybody to respond to it, because if it's only folks in your organization, then it might limit some people from responding to it.
I put it on all. Did it
Oh,
work?
okay.
Because
I,
I saw that it does pick up my university, but then I actually hit the one that says anyone can respond
okay,
to.
good, perfect.
You know if it's not working.
I think Glory had an issue with it last time.
Oh,
But we'll see. Glory, she's one of our students.
okay.
Um, but we'll see this time if everything works well.
Oh, yeah.
And
I'll pay attention just in case. But I think I really did that. Let's see how she takes it today.
okay,
Yes, thank you for that advice.
okay, great. Let's see.
Is it already showing some signs of winter over there?
It's cooled down just a little bit, not a ton. Um, let's see. Let me pause.
Thank you very much. Let me share. Did you give me the ability to?
Oh, let's see. Yes, you should be able to.
Okay. Can you see?
Yeah.
Yes. All right. Good morning, everyone. It's good to see you again. I hope you can hear me clearly. Today we are looking at extreme weather and climate change. I know that in regular terms, in general terms, we don't always talk about events as extreme weather events. Normally, people just talk about disasters. Can somebody tell me the difference? Anyone who's not busy with their a survey?
Difference between extreme weather and a disaster.
And disasters, yeah, just disasters in general. What is the difference?
Extreme weather is more so consistent. Whereas a disastrous event is kind of like a certain period of time. It may not happen again for several, for example, maybe months or maybe or years in some cases in a particular area. Whereas weather is more consistent.
Okay, so you would think that extreme weather events are more frequent than regular disasters, right?
Yes.
Okay, thank you so much, Caldren. Anyone else to add something else to that? Because we also want to kind of understand what disasters are so that we can relate to today's topic. Thank you so much, Caldren. Somebody else?
Look, I think extreme, like just to add to what Cardrina said, is what we experience on a daily basis that is constantly happening. But the disaster will just be once in a while due to natural, it could be natural, that happens once in a while.
Okay, thank you, Glory, for your response. You added something else there. You said it can be natural. If it's not natural, what is somebody else can pick it? Thank you, Glory. You can add if you want to add something to that. All right, but you are helping us with the discussion. We want that. We want that. Discussions are good. I just wanted to highlight the fact that we have events that can actually be geological. And then we have the events that are hydrometeorological, which means they have to do with weather and climate. And then we also have what we call a man-made. We just got used to saying man-made, but now perhaps because of gender issues, now we move away from man-made to maybe just use the concept of anthropogenic disasters or events, because they only become disasters when they affect people. But extreme weather is also a form of an event that falls under hydrometeorological events. It means that it has to do with weather and climate. So it's only a portion of the disasters we have in the world. And this is what we are dealing with today. And as you can see in the topic, it actually says that climate change is increasing the intensity and the frequency, as you were saying, Glory there, and Caldrian. So can you give me examples? One more question. Sorry to bug you with these questions. I just wanted us to start from a point of view where you guys are, we're coming from where and then we go to other areas that you may need extra information. What are these weather events? Can you just give me examples?
A drought.
Yes, that's right. Any other examples from anyone else?
We have let's say low production in crop.
Sorry, we're kind of picking out there, Chloe.
Okay, like a hurricane, you have the issue of
yes.
Hurricane?
Yes, I hear you saying hurricane, typhoons, or cyclones. One and the same thing. Yes, that's right.
Cyclones. Yes.
That's right. That's right. And
hello, doctor.
Yes.
Heat waves.
Yes.
Heat waves.
That's good. Thank you very much. So we'll be talking about this. But
hello, doctor.
Yes. Go ahead. Go ahead.
How about floods?
Yes, floods are correct, Brenda. Thank you very much. But I wanted you to notice that, did you know that these extreme weather events, because of the input of men, because of the impact of men, humans on our climate, that we all know, we've been actually getting very good classes or very good lectures from this course through Dr. Panasik. We do have those events that are going to fall between, or they are going to take a little bit of the anthropogenic aspect and a little bit of the natural or extreme weather form. For example, drought, which you talked about, Caldrian. We know that humans contribute to drought through processes of deforestation and all that. So now they no longer stand as extreme weather events alone or only. They are what we call quasi quasi-natural or quasi-anthropogenic events. Whilst this is really hydrometeorological, it's a class on its own, but they kind of fall in between. So when we classify events, we will see that there will be an overlap. There will be natural, and then there will be the quasi-natural, and then we'll have the human or the anthropogenic or the ones that are influenced by humans, because as humans carry out their activities, they then influence also the natural. So they fall in between. So drought is one of them. Even wildfires, because humans can participate in that. But in all of that, we want to see the greater role of climate change. So I have a list here, and it's not even the whole list. Heat waves, floods, drought, which you mentioned, and thunderstorms, especially the ones that become supercells. And these are the ones that usually tornadoes connect to in order to, move, like in the US, in the tornado alley, they stretch all the way from Texas, going north. These thunderstorms in themselves, even without connecting to tornadoes, can be very disastrous. So you mentioned cyclones or hurricanes or typhoons, and also hailstones. And then with the thunderstorms also comes lightning, which is a very important feature because it's actually very destructive, especially if you look at the thunderstorms we experience in the US. Then we have severe snowstorms. Sometimes we forget the cold when we are just looking at these disastrous climate change related events. We think of those where the warming is actually resulting in heat. I think you have done so much in that area, and you are very clear that there's no doubt about it. The temperature is rising. But while the temperature is rising, as you shall see, it also causes some areas to experience snowstorms. Well, who heard about the Texas deep freeze? Who heard about it? Anyone? If you haven't, we'll talk a little bit about that because I decided to use a case study approach for this class today. So we talk about an event and then we look in the world where something of that nature is happening. So the Texas deep freeze event is when there were very, very low temperatures that were experienced in Texas, and it actually became extremely cold, and there was snow in some areas. And I know that even California experienced a little bit of that. So we are going to get back to that because I have some pictures to show you on that. And then America at some point experienced dust bowls. And so these dust bowls can also be anywhere in the world, very typical of desert areas. And they are related to wind movement, and therefore it's also part of weather. So we can talk about that. And the most exciting for me in this area these days would be the permafrost melt. And we'll also share, I'll share some pictures, with you to see what's happening in Europe. So some observations that have been made concerning the extreme events. I just made some bullet ideas that you could take advantage of even when you do your exercise, because after this class, you're also going to do another flip recording, and I've chosen for you 2 events, which I thought you can easily find material on. I've picked the hurricanes and tornadoes for you. So you choose between the 2, so you can do your flip for 5 minutes on those events. I've left those out. But when we are going through the other events, make sure that you are also already earmarking some ideas that you want to put in your flip, in your assignment. So generally, I'll pick a few, or maybe let me start with you. Just pick any and maybe explain. Let's see how far you can go. Any idea that you see on my list, and then you can share. I think that way we keep the discussion going. Yes, let's have you go, Calvin.
A record-breaking weather event.
Yes, so in what way are extreme events record-breaking?
Oh, okay. Let me think of an example.
Yes.
I'm not sure if this is an correct example, but from last meeting, Dr. Fanastic would explain that the last 15 years, within the last 15 years, 13 of those years were actually record-breaking temperatures. I think he was referring to the United States,
Yes.
if I'm not mistaken.
Okay.
13 of the last 15 years, the average temperature has been record-breaking. From I think that's a I think
It's a global
that's
statistic, actually.
okay, global. Okay.
All right. So you see what we're talking about. We're already characterizing the extreme events, and it's very good that you are linking what you have done with what we are doing today. I like that. So it's record breaking because history gives us the standard. It gives us the parameters that we are used to. And when I suppose when he was even giving you those statistics, he was actually showing you how what we knew as the standard has changed because of climate change. And so that's good. Let me take another contribution. Anyone pick on any of the points and share. Tell us what you think about extreme weather events relating to that point which you picked. All right, I can go with my favorite, which is this one, that extreme weather events trigger other non-weather events, geological events. I was thinking about landslides, how when it rains and we have such intense rain, especially in areas where it is not expected, for example, California being a dry place most of the time, the rains that we have would be like flash floods. And with the bare soils, especially after the fires that you always hear about, you find that landslides can easily be triggered because that rain will mix with the soil. It will actually form mud flows. It will even dislodge, steady land, which is within the mountains, like steady granite rocks that already have been fixed in the mountains for a long time, but perhaps they were disconnected through weathering. But the existence of those rains, heavy rains, even if it gets to flooding levels, will just dislodge all these, geological aspects, or the geological nature of that land will be disrupted. It will be changed because there will be a slip of the land from off of the high areas. And also related to that, already in landslides, we have avalanches. So avalanches are related to extreme weather events because we have snow there. And so when people go out there and, start snowboarding and all that that they do on the snow, that might also trigger, even further avalanches because humans are a trigger by themselves. So there is so much that we can talk about. Can you imagine if you were writing an essay, you could actually write 3 different essays from all this stuff. The weather events are becoming more forceful and more intense. And this survey, I got it from our major climate related organizations and also the government ones. We have FEMA, we have the USGS, especially here in the West Coast, very active in all of the weather and non-weather events. We also, deal with information from NASA and then IPCC. There is so much that they are giving us. I think America stands at a good position where there is so much information. And then again, we also compare it with the European sources because we have so many geographers in these areas of the world, the ones in America, the ones in Europe, giving us a lot of detail, a lot of case studies. Especially nowadays because of the improvement in our technology and, being it a time when information is easy to relate. There are so many things that are happening. So the disasters are more destructive, these weather events, they are more destructive, but take note that they are varied. They will not be the same. Even if it's a hurricane, it will not be the same. There are hurricanes that already stand out. We know of Hurricane Katrina, Hurricane Sandy, those names stand out. And for Africa, we had a very strange hurricane, which was Cyclone Idai that came in 2019. Normally, cyclones disappear or they fizzle out when they get on the land. But this particular cyclone went back. It really made a U-turn and went back to the ocean to get more energy, and came back for the second time and had an onslaught in some communities in Mozambique, Zimbabwe, and Malawi. And so many people died and a whole city was destroyed. So we are seeing a behavior change in these extreme events. That's why we're saying they are more intense, they are more forceful. Hurricane Katrina itself was expected to be a category 3, but it ended up in a category 5. So these events are very, very intense in their presentation and also in their connectivity among themselves, as well as also connecting to other events which are geological. I know for a fact that hurricanes, when they die out, remember they start as a supercell, as a thunderstorm over the oceans in the tropics, they go inland. And then when they dissipate, that cloud that remains there, which turns back almost to a thunderstorm cloud, can actually spawn tornadoes. So now with the increase in temperatures, terrestrial and maritime, you find that there is that intense connectivity among hurricanes and tornadoes. Of course, most tornadoes are terrestrial, but we do have also a tornado that is spawned on the waters. So whether the tornadoes will be spawned on water or it will be spawned on land, that varies from place to place. But our earth is warmer now and is wetter because of these high rainfall totals that we are having in some parts, because we talked about varied presentation. And also I saw a part of Dr. Panasik's presentation, I think on the impacts, that was really highlighted very, very well, to say that the presentations or the impacts are going to vary from place to place. It will connect now with what we talked about concerning patterns of weather. So that is very important. And another key aspect that I wanted to highlight was that of threat multipliers. What are threats? When we look at events, the things that are shocks and stress and that cause people to go through and experience difficulty, we normally just classify them as threats. So extreme weather events are threat multipliers, which means whatever the people were experiencing, whatever the environment has been experiencing, it's multiplied maybe even tenfold because of the intensity of the events. And these events, it's not like we're looking forward to them. They are already happening. I'm talking about Cyclone Idai in Zimbabwe, which was actually far inland and was not supposed to have an intense cyclone like that. But we have cyclones reaching Zimbabwe still extremely strong. And these are the threats that now people face, which they never faced before. So these impacts are already noted. And I think you're still going to do more in that area. But let's see now, what is it that is extreme about them? I threw in a few ideas, and I was actually putting these in quotes because this is what people are saying. This is what even the news is capturing. Oh, these are unexpected, unusual, unseasonal, dramatic, the new normal, erratic. And one guy even said, it's like our weather is on steroids. I thought this is now like just two way into, making fun out of what is happening, because I can imagine it's uncontrollable. But our history, which gives us the standard or the parameters, is showing that things are now different. And we know the cause being that of climate change. So let's see a few case studies, perhaps after this slide. This, I threw it in, but I know Dr. Panasik has already done a very good job with showing the temperature increase. But I just wanted you to also see that there we have that orange, that red. You can see that by 2022, we had so much increase in environmental temperature. And so what is it doing? This was captured by CNN, and it made me kind of like go back and say, okay, if the record in 2023 shows that the average global temperature is 17 degrees. And in 2016, it was 16. What was it in 2014? What was it in 2010? And I actually realized that it really corresponds to that diagram because I put some figures down. I wrote them down. Hold on, give me a minute. Because I was just fascinated by that to say, okay, what's going on? And I noted that in 2013, but that it depends on the source. This one was from, the source that I got was from IPCC. It actually showed in one of the reports that by 2014, it was actually around 14 degrees Celsius. By 2000, it was less than that. So we can see that gradual increase showing even here with the 2016 figure, with the 2023 figure. The increase on average is actually very clear. So we want to continue in that respect, knowing that the temperatures are going up. And this one was given by the World Health Organization, showing that generally the world is experiencing higher temperatures. Their concern was the health component because they know that the heat waves and also just the uncomfortable high temperatures will affect people's health. So this map comes from the World Health Organization to warn people about the killer heat waves. And that was going to be my first case study. Europe is actually known to be one of the areas in the world where a lot of heat waves are experienced. Look at that green and blue map. It shows that the temperatures, regular temperatures in Europe would range from about 50 something to about 90 something. And you can just scale up and go up and down and see the differences. But this is a general temperature in terms of average temperatures, but not necessarily the highest and the lowest. But look at the red map to the right. It now shows that the range, the 50s jumped to the 70s, the 80s jumped to the 100s. So now we have much more of this temperature increase experience, especially during the summer. But the one thing that you have to take note about this issue is that these are temperate regions, and some of them might be in the subtropicals. But these are places where people are used to having, cool weather throughout the whole year. And you can imagine the impact that this has on the people. It's not like people who live in the tropics who are already used to the heat. So that's why even the heat waves are more, actually their impact is much greater there because we are jumping, sorry, my mouse just moved too fast for me there. So I have this picture that I actually saw online. Of course, I know his this guy's face is protected because he's looking down. This amazed me to say 62,000 people dying from a heat wave in Europe. And this is not even far from now. So we are talking about reality. These are things that are going down. And according to the World Health Organization, they were saying heat waves are now a silent killer, almost like cancer. But people are not talking about it so much, which is the problem because it says victims are undercounted. So this is something that needs to be improved, especially in data collection, to make sure that all the extreme weather events are catered for and they are actually put in, repositories. The information, the data needs to be shared. Because sometimes if you miss the news, that's it. But then we need this spoken about. That's what the World Health Organization is worried about, that people are not being informed enough to know that there is a danger out there during the time when actually it's summer, especially in the Northern Hemisphere for the Europeans. The temperate, climate that they are used to, when the temperature rises, it's a marked difference, for them as compared to perhaps people living in the tropics already, where the temperatures are very high. So that difference really has an impact on people's health. Sorry.
Sorry, Doc.
Yes.
Sorry, just out of interest sake, you said these statistics were recorded in the year 2023. I'm just interested to know because it's quite a number for which have been affected by this heat wave.
Yes.
Does it have like the age group, or what age group is really affected by this? And their demographics, like for example, their
I hear you.
their way of living, maybe are they older or younger, or do they exercise or what? Because it's quite a number, 62
Yeah.
in only. Yeah.
And thank you so much for that question. And remember, it's also not one country, it's the continent of Europe. And I would bring back that question to the class. I would actually ask the class to answer that, because we have vulnerable populations. Who do you think is more vulnerable when it comes to heat waves? It's a good question, which makes us expand our horizon. Anyone who wants to take that one?
I'll take that one.
Yes.
So when we look at the health of a population starting from infants to geriatric, we are adults. So the young ones as well as the old ones, the ones that that fall under the category of geriatric. So the little ones, will allow me to call them, and like pediatrics, because these are at the children are at a stage where biologically, physiologically, they haven't developed their body system to match what happens to the environment outside. Yes, there are micro factors within the body that can regulate homeostasis, as well as like water retention, wherein a whole lot of factors come in, which includes like kidneys and the skin helping in like preventing heat loss and moisture. But at the same time, they haven't developed to the point that they can regulate the extreme temperatures that they are exposed to. Also, there is what is called hypothermic shock. There is this shock that is associated with increased temperatures. So we can take an example when someone gets sick. The moment when you are sick, your body, you feel fever. That fever is developed from a state where in the body, the body increases its temperature to try and help maintain that environment that the immunity fights bacteria. But the same temperature can also kill you as an individual. But that's just the defense mechanism of the body. So things like that, where there is an extreme temperature that the body is exposed to, that is beyond the coping mechanism of the skin as well as the kidney and other biological functions within the body. They make it difficult for one to cope. And the body organs, when they are, such as the brain, especially when it's put in such a condition, it gets to a point where it dies. This is where people die. So they might die due to dehydration. Some might die due to organ failure because of high temperatures. This is the same as with the elderly population. These have lived their lives and their bodies have just weakened in terms of strength to withstand these extreme weather temperatures.
Yes.
So allow me to leave it there.
Oh, thank you so much, Desire. That was really detailed. And what we are taking away from your point is that we have the elderly, we have the children, they are vulnerable. Let's have somebody else also add to the vulnerable population. Who else is vulnerable? Because it's more than that. Thank you so much, Desire, for setting us on course. Anyone else? You want to share, Caldrian?
Possibly individuals with underlying health conditions.
Yes, that will count. And anyone else? Thank you so much. Think about the people who someone's coming up with something, because I can't see all of you. Go ahead.
I think those who are also more closer to the occurrence of the event.
Of the heat wave. Okay. Ground zero. All right. I'm not sure how to actually find the ground zero for heat waves, but we can talk about that another time. But that is the exposure to the heat wave. And then I was going to say, think about people who actually carry out their day-to-day activities outside, outdoors. Those who work outdoors, construction people that are always exposed will be more vulnerable. Think of the homeless. who have no shelter, who have nowhere to go. They don't have choices. Some people are actually just, supposed to just get in the house and have their aircon running. And so they don't have that choice. So people who have no choices are also vulnerable. So we can go on and on and on. But thank you so much for that question. And it made us, discuss this whole idea of making sure that we map out our vulnerable populations. And I would like you to also do that with your choice extreme event. All right, let's see other case studies I have. This one, like I said, this is very exciting for me. Not that it's good, but the fact that, a huge geological feature such as the mountain can just crumble because permafrost within its, interior layers is actually melting. I thought that was very, very, maybe I don't want it to look like I'm excited, for the event happening, but I'm saying that it is dramatic. It is something that you don't hear of a mountain collapsing, because mountains are collapsing in Europe, especially the Swiss mountains. They are falling apart because the ice is not just on the top layers of the mountain, it's also within the layers of the mountain. And therefore, having this ice stayed there for many, many years after glaciation took place. And then obviously with some of them, volcanic activities took place. They were different layers, some of them which could absorb water and crystallize. So we are looking at now those interior layers of the mountain melting out and therefore the mountain collapsing. Actually, there is an event that's talked about, and you can easily Google it and find it on YouTube, where a whole family had actually gone there to have their, mountain ski thing. And they actually fell into a trench that was created because of the permafrost melting. And this is a new phenomena that we are seeing in Europe in particular. So it's still an extreme weather event, but you can see how there is that connectivity with the geological, happenings, because a mountain is geological. And now we see how an extreme weather event can actually bring those two together. So the connectivity, when you talk about your events, make sure you also check the connectivity with other events which may not be weather related. Now, I actually like pictures. I think you must have noticed that. I like pictures because I think pictures are worth more than 1,000 words. So you can see with this one, it's now fires, forest fires. I dreaded to actually start with America because we want to always go back, and it's almost like comparing everything else with what is going on here, because this course is actually in the US. So we always touch the US. So another place where there is an increase in fires is Europe. And it's very clear, even with NASA, this is a NASA report, which shows that there is so much land or forest cover that is being destroyed in Europe because of climate change related heat. Because we want to also not be so blinded in to say that everything that's happening is because of climate change, because wildfires can actually start. In Africa, some of the wildfires in the savannas are started deliberately because of the system that they use to actually clear the land and make sure that the land is ready to sprout new grass and new trees. And then other fires also start because of lightning and all that. So fires start from different reasons. But what we are talking about is an intensity in the heat so much that even the natural forces are ignited. And so we can see even on that NASA report, 200,000 hectares of land destroyed in Spain. That is a whole lot. 57,600 hectares. I think some of you guys who are carrying out land-based activities, you might be able to, estimate for us 79,000 for Portugal and Italy. So these are just forests burning as a result of the increase in temperatures. And so we want to be aware that climate change has its contribution, but we do have conditions that we understand according to the what is called the fire triangle, we need oxygen, we need heat, we need the fuel. So can somebody tell me what the fuel is in a fire?
Oxygen, personally.
Oxygen will make it burn. That's why when you put a candle under, and cover it, it's gonna actually switch off after a few seconds because the oxygen is out. But what is the fuel? What makes the fuel? So we have oxygen, yes, I agree. And then
it's the hydrocarbons within the structures of plants and it's mainly plants.
yes, the biomass, that which is going to burn is the fuel. Just remember it that way in its simplest form. And then you can actually then relate it to scientifically. Start with just the basics. And I want you to do that and go on to give the scientific explanation, which shows that at least now you are moving somewhere at another level. I love that. But the fuel is just those trees, the dead grass, the trees. And sometimes for wildfires, the trees don't have to be dead at all. The fresh trees, the fire as it is encroaching, it begins to actually suck out moisture from the trees uphill as it is going uphill. By the time the real fire catches on to those wet forests, they are no longer wet, they are already dry. So the fire is so systematic in the way it destroys vegetation cover. So now, you tell me, so what is the connection between the abundance of fuel and climate change, which is resulting in all these fires sprouting out?
Come again?
What would be the connection? Why are we having so much fuel during this time of climate change? Because this is
with warmer temperatures on average, that will thus result in a lot drier lands. Warmer temperatures will equal a lot drier lands, and thus creating more fuel essentially for fires to catch. So essentially, it's kind of like a snowball effect. Higher temperatures equal drier lands. Drier lands equal the abilities for forest fires to expand farther and greater than they normally would.
Yes, that is very true. There is more drought. There are more clear areas that are having fires. Imagine the Amazonia fire, the Australian fire, the Maui fire. Those fires are way beyond the normal because of the intense, heat that we have that is drying up a lot of places because of drought. And I want you to remember that the drivers for most forest fires is what you already know, the surging temperatures, the heat waves we talked about, and also the decreasing rainfall. Because if there is abundance of rainfall, in most areas we'll have a lot of green cover, and therefore the fuel is not as prepared, for the fires as what is happening now. And I'm looking at my time and I want us to go fast because I'm going to share this. You can also look at that, which talks about, deforestation and how now it's changing weather patterns and therefore making places prone to fires so that we can cover more ground. And for America, I always say that we always end up having an example for America. Look at that rise in fires that burned in the US. And there are many states in the west coast of America that are actually drier and prone to wildfires. One of the main reasons, there are different reasons, and some of them are actually isolated reasons why fires start. But we also understand that on this part of the ocean, the Pacific, we actually have a cold water body called the Californian current. And the Californian current is cold. And when we have winds blowing over it, it doesn't result in much rain on the coastal areas. We have the desert, the Mojave Desert, and many deserts along the coast because the moisture, the little moisture in the winds that actually arrive on the west coast forms fog. So we have a lot of fog there instead of rain. So these are dry lands. This part of America is relatively dry. And then there are also other reasons that we talked about, the terrain and all that, which may cause other places to even have greater dryness because of their local conditions. But you can see that they are very high or significant number of fires as compared to the East Coast, which is much cooler. And we can explore that too when we go back to talk about temperature, which really characterizes climate change. It's a major issue. So let's see. This is the Maui fires in Hawaii. I think you heard about it. I was happy to see that I could actually get this slide, which showed how it was before, what was happening during the burning, and also what was the aftermath of such a beautiful place turning into that. So we have had a very wide number of examples showing that the land can actually be totally destroyed. Here is the point here. When they talk about the Maui fires, they actually say, oh, it was a downed power line that caused that. But then the land had already been prepared for the fire because there was a drought, a major drought in Hawaii. So when we talk about, causation, make sure that you talk about the immediate, which would be the power line dropping and then the fire starting. But let's also talk about the long-term effects of climate change in these areas. So that is very important to highlight. So there is a big story there concerning the Maui fire. And the same thing also with the issue of Arizona and also the heat that was experienced in Arizona. What is important here to note is that, of course, in the summer period, there were high, very high, temperatures, and you can see the month of July, it's showing that. But compare with what was experienced in the winter, low of 34, high of 59, low of 45, high of 75. All of a sudden, we jump from 59, 75, and 95 to 115, 118. That's a high jump, and people actually suffered a lot. And again, we go back to vulnerable populations. Who was more vulnerable in the Arizona summer highs? And this is important to note, because people are going to be impacted differently because of their different vulnerabilities, as one of you already highlighted. But it was a stretch of 19 days with more than 110 degrees Fahrenheit. This is degrees Fahrenheit. And you can also compare that with the degrees Celsius. And the causation here, people are talking about the El Nino affecting this part of the US. But what is it about the El Nino? Who knows about the El Nino and the La Nina? These are events that naturally occur. They don't have to wait for climate change to happen. But what we know now from the records of IPCC and also NASA is that generally there is a change in the water circulation, the movement of winds and also surface temperatures in the Pacific Ocean. So this would be the normal situation. But when an El Nino happens, then it means that the trade winds decrease their strength and therefore they do not go as far as they are supposed to. So we actually have the places which normally would receive rainfall. They do not receive the rainfall, but the rainfall is received on the other side of the Pacific. And we can explore, like I said, we can explore the El Nino La Nina effect. And I think the La Nina will be the next one, this one, which is the opposite of the El Nino. So, but it is also a high, it's almost like the normal situation has been enhanced. So what is happening with these winds and also the surface temperature of the seas? It is actually changing the presentation of climate, of weather in those areas, mostly in the Pacific, but it does happen in the Indian Ocean. It also happens in other places. It's just that when the El Nino La Nina effect was being talked about originally, they focused on the Pacific Ocean. But we do know that some of the places in East Africa are affected a lot by the El Nino La Nina effect. So there is an understanding that we get from IPCC that climate change actually enhances the El Nino La Nina. It's still debatable, and people are actually even saying, is that right? Have we collected enough data to prove this? But knowing what temperatures are actually, how temperatures are going up, obviously the temperatures are also felt on the waters in the ocean. So where there is upwelling, once that upwelling, the salty water from the bottom of the ocean comes up, there it meets high temperatures, which are actually in the tropics, as well as being now enhanced by climate change. definitely even the movement of that wind, even the movement, the evaporation which is going to happen from the ocean surfaces is going to be intensified. This is the argument. So the El Nino and La Nina effect that we have is no longer the regular one. It's an enhanced one. And this is the argument that put forward by IPCC. So we can see that even though in Arizona, the problem that resulted in those temperatures going high is attributed to the El Nino effect, we know that the climate situation is actually enhancing also the causation of droughts and also floods. So with the El Nino La Nina, where there was rainfall, it will be drought. And when there was no rainfall, it will be wet, which causes also other disasters like landslides. We had so much rain this year in California, so much that it was actually now destroying landscapes and infrastructure because the land has not been used to receiving all these rains and the vegetation is poor. So all that is important to pull together to say that, yes, we understand these are phenomena which are outside of what we are discussing, but climate change seems to be increasing that. I see my time is almost up, but I was going to just share quickly, just give me 5 minutes if it's okay with you, Dr. Panasik. The issue of floods. We have floods in Germany and floods in Belgium, another extreme event. These areas never used to have this much water. It's not only in Europe. Look at Africa. The heavy rains that fell in Nigeria did not only fall in Nigeria, they fell also in neighboring countries. It was a regional upsurge of flooding. And we know that flooding comes from different sources. It can be a dam break and there's a flood. It can be heavy rains and there's a flood. I think I did put some different reasons. Yeah, it could be polar ice melting. It could be a storm surge, especially when you deal with your hurricanes. The water that drowned Mississippi and Louisiana, it wasn't just the rains falling from the sky. It was the wind, because tornadoes and hurricanes are wind systems. It was pushing the water onto the land. But then, unfortunately for those states where there were walls that had been built, which they just used to call levees, those had been weak and they had been in existence for many, perhaps decades. So they were weak, and now Category 5, Hurricane Katrina just destroyed those and found its way onto the low-lying areas of the Gulf area. So it's important to know, when you are talking even about flooding in general, to find its source. Is it because of a storm surge, which is what I just explained? Is it because of polar ice melting? This picture you see here is actually Jakarta in Indonesia. And it has been actually receiving water from the sea. And therefore, people are actually already saying, yes, we can see that the land is drowning. This is a place that is drowning because of melting of polar ice. So I like the first point, which says air can hold, I think, Dr. Panasik, this would be your area, air can hold 7% more water vapor for every 1 degree Celsius in temperature. So now we are talking about the tests now that is in the wind, or also in the wind system, such as hurricanes and tornadoes. They will collect all that moisture and water and heat from the water, and they will become supercells even in thunderstorm stage, and therefore become very humongous and very aggressive. How does a Category 2 hurricane change to a Category 5? And that's Hurricane Katrina. When it zoomed into the Gulf coast, it actually just got that warm because it feeds off of that moisture and heat. So we are talking about many sources of flooding, but which one affects the scenario or the case study you are dealing with? But we have to also know that the change in climate is now making it easy for that water which is already there in the soil, in the open water sources, the internal or the inland waterways, as well as the ocean, to be super evaporated. If it's from plants, it's super transpiration. So super evapotranspiration. And therefore, even the rains that fall, like the ones that fell in Africa, around West Africa, in Nigeria and others, Cameroon and others, were so intense and they lasted very, very long. So all that is something worth considering. And then as for drought, since I will share this with you, drought again is being impacted greatly by climate change. So it's coming from the El Nino La Nina effect. You know, when there's the La Nina, which is usually 2 years after the El Nino, we have drought spells. So these are now enhanced because the super heating of the the ocean surfaces for the El Nino, and then the opposite actually also causing, you know, slowing down of the movement of the water in the oceans. And that we know that these determine climate, these determine events on the land. So when these winds bring less moisture or bring more moisture, we have on one side drought, on the other side we have flooding. So when we talk about droughts in relation to the El Nino La Nina, you know that whatever used to happen there is the opposite of it. But there are other causes for drought, like I said, the one where the water bodies on the western side of continents can actually bring fog instead of bringing rain. So we have reduced rising of the updrafts, and therefore less condensation, less cloud cover, less clouds that are productive, such as the nimbostratus and the cumulonimbus. We don't have all that. So climate change is really altering how the wind systems are moving and the distribution of temperatures, as you all know. So it actually just lowers the chances of some places getting rain. So drought is prevalent and it will vary from one place to the other. We have drought in dry deserts, and we also have drought in hot deserts. So I think for today, we can end here. Sorry to have gone beyond Dr. Panasik. I've already set the assignments and I will send it to you, Dr. Panasik, so you can share with the students. Thank you very much, guys. If you have questions, when we meet next, because we're meeting again next week, I will be able to address those.
Thank you very much. If you go ahead, send me the PowerPoint too, so I can post it up on the LMS and resend it to everybody. Thank you very much, Dr. Furusa.
I'll do that. I'll certainly do that. And what I'll do, Dr. Panasik, is because I didn't finish the few slides left, I'll just send it together with that, so that when we have time, we go through. I think there are like 3 more slides left, but I will just put it together, even though I didn't explain.
This was great. Thank you.
All right. Thank you so much, class. Bye.
Thank you, Doctor.
All right. Thank you, Jay.